So linear motion, type 3, no speed limit. So for these ones, sometimes it's combined with type 2, where we have part 1 of the question has a speed limit and part 2 doesn't have a speed limit. But for the sake of revision, I've done them as 2 separate questions. So I've chosen 2 questions that have them. One is just a velocity time graph with a constant speed in it, and then the second one has a no speed limit. So with no speed limits, basically, it's going to reach, trying to cover the distance in the shortest amount of time. So it's literally going to be acceleration followed by deceleration. Now, just whatever way I copied across the question here, can I just note that these units should obviously be meters per second squared. So the power there didn't work. So if you just change those units, so that should be, again, meters per second squared there. So first thing we're going to do is draw the graph. And when we draw the graph, we're going to state our relationship. And then we're going to find the distance descended. So again, drawing these graphs, we have to remember that the key to this question is going to be that the ratio of the times, t1 is to t2, is the ratio of the acceleration, so the deceleration to the acceleration. So that's the key for this question. So we're going to draw the velocity time graph first. So we have our velocity in meters per second on the y-axis and our time in seconds on the x-axis. And it's accelerating at 0.6 and decelerating at 0.8. It's a little bit steeper on the way down. So we have a bit more of a slow slope going up, followed by a steeper slope coming down. So just exaggerate it a little bit. And then I'm going to break that down into stage 1 of my journey and stage 2. And on it, I'm going to mark my acceleration and my deceleration. So that's acceleration and deceleration, time 1 and time 2. I don't know what their distance or what their times are, but I do know this relationship. T1 is to T2 is equal to D is to A. So I can then sub in to this equation my deceleration, 0.8, is to my acceleration, which is 0.6. So therefore, what that means is that the total parts is equal to 0.8 plus 0.6, which gives us 1.4. So therefore, T1 is equal to 0.8 over 1.4 of the total time. And that simplifies down to 4/7 of the total time. And if I do that then for T2, well, T2 is 0.6 over 1.4 of the total time. In other words, it is 3/7 of the total time. Now, if I go back to the question, I can actually see the time from rest to rest is 14 seconds. So in other words, I actually know what the total time is. So therefore, that allows me to work out the time taken for each stage of the journey by simply subbing in 14. So therefore, that gives me the first stage of the journey took 8 seconds. And the second stage of the journey, well, I can just simply subtract it from 14. Or I can sub in the 14 into my equation and I can see that I have 6 seconds. So 8 seconds for the first stage and 6 seconds for the second stage of the journey. So now all I have to do is find the distance descended. Now to find the distance descended, I need to basically find the area under the curve. So I just push that up. So my distance is equal to the area under the curve, which is half the base by the perpendicular height. But we don't know what V is yet, so we're going to have to work out what is V first of all. So I'll just take stage 1 of the journey. We could take stage 2 either, it doesn't matter. So whichever has the information, but in both cases I have information now, so it doesn't matter which one I use. So therefore my height is my velocity, my acceleration is 0.6, and my time is 8. So remember, in these triangles, you're not using Pythagoras. It's not a right angle triangle we're looking at. It's velocity, acceleration, and time. In other words, acceleration is velocity over time. And therefore, if I sub in there and I want to get v on its own, well, v will be the acceleration 0.6 by the time, which is 8. And therefore, my velocity, maximum velocity reached, is 4.8 meters per second. Perfect. So now all I have to do is, well, my total time taken was 14 seconds. So if I just draw an overall triangle, and I have my perpendicular height, well, we've just worked that out to be 4.8. And my base was the total time, which is 14. So I simply have to go half the base by the perpendicular height, which gives us a distance of 33.6 meters. So in other words, the distance that the lift descends is 33.6 meters. And again, we know this is a 20 mark question, but as I said in the previous example, I've left the marking schemes in school. I think I have the 1994 one there, and I can break down the marks further for you, but in total the question was 20 marks.